Hello, my name is Scott. This is my robot head demonstration for SEE 215. This is the robot head that I've made. It's a 3D model. I started by downloading a 3D model of Thingiverse. I imported that model into Autodesk Inventor, where I positioned all servo mounts for my servos to control the eyes and eyebrows. Once I had those in position, I imported the mesh and the solid files into Rhino, where I stitched all together, shelled out the 3D model that I downloaded, and printed out on my printer. I went through a few different iterations to get all my fits correct, but I ended up with a model that was quite compact. I could fit all my motors in. I used micro servos for the eyebrows and the eyes, and I have horizontal and vertical control of the eyes, as well as independent control of the eyebrows, and I use a larger servo for the jaw, just to give it a bit more power. The jaw is mounted on ball bearings in here and directly to the servo arm here. My eyeball gimbals are built around a ball joint and a piece of Lego. I attach magnets to the servo horns, ball joints to the servo horns and magnets to the eye socket. And that allows me to have up and down and left and right movement. And then everything's bolted in with a support piece at Deakin University. Alright, so I'll just quickly show you the operation of the robot, and then I'll go into detail on how it works software wise. So this is the default expression 1, which is angry, eyebrows up, his head lights up red. Expression 2, he's supposed to be a bit sad, looking down. Expression 3, cross-eyed. Expression 4, a bit crazy. Expression 5, looking down. And return to expression 0, or neutral. I power the unit with a 12 volt lithium ion battery, and to bring down the voltages I run it through two 7806 voltage regulators that drop the voltage down to 6 volts, and I'm using a breakout shield, terminal shield for the Ethomega, and it's good. It gives me a little prototyping area where I can put in the voltage regulators and make a rail where all my servos are using 6 volt, but I can supply a lot more current than the Arduino Mega. The battery pack also can power the Arduino by itself, and then I also power my LEDs off the Arduino through some resistors, and that comes in through this wire. I've only got one LED connected at the moment. The other one's just a plug socket there. I did put in an ultrasonic sensor, but I haven't got it working for this demonstration. There's a few Arduino libraries that I need to convert into C code. I'm using 2 interrupts in my software. Interrupt 1 is using is a serial monitor, where I have a debugging script that I can tell when I push my button. I have button count. That tells me my expressions. So that's my first interrupt, the serial interrupt. And the second interrupt is a timer interrupt that I use for debouncing the button. And what I do is I have the buttons attached to port C, and I create a timer interrupt that interrupts every 5 milliseconds. and after each interrupt, it looks at the whole of port C, and if there's a change in any of the pins from the previous scan, then it flags which pins have changed. And then if I get 3 consecutive stable changes, so if one pin's high for 3 lots of 5 milliseconds, then it's counted as a latched pin, and then I add that to the main loop.